Lying 4.5 billion kilometers away, Neptune is the farthest and least explored planet in the solar system. Voyager 2 is the only spacecraft that has ever visited the far-flung world, and that too during a flyby in 1989. So there are many things that we don't know about this ice giant. Also, very few modern telescopes on Earth can make detailed observations of this planet. And now 17 years of data show that something weird has been happening on Neptune since 2003. Neptune's axial tilt is 28.32 degrees, which is close to that of Earth. Hence, Neptune experiences seasonal changes similar to our planet. But it's so far away in the solar system that it takes 165 Earth years to complete one orbit around the Sun. This means that each season on Neptune lasts for 4 decades. The planet's southern hemisphere is currently in the middle of an epic 40-year-long summer. But according to a recent study published by the American Astronomical Society in the Planetary Science Journal, the strange thing is that the temperature isn't rising in that region of the planet. Instead, it's the opposite that's happening there. The average temperature has fallen by 8 degrees Celsius since the beginning of the summer. Summers in Neptune's southern hemisphere began in 2005. Since the researchers have combined the data from 2003 to 2020, they have been observing the planet pretty much since the beginning of the season. Data shows that Neptune's stratosphere unexpectedly cooled down between 2003 and 2009. The researchers made the discovery after examining nearly 100 thermal infrared images of Neptune taken over 17 years. 6 major telescopes contributed to this research, but the central role was played by the European Southern Observatory's Very Large Telescope, or VLT for short. VLT is a ground-based telescope but can photograph Neptune at par with the Hubble Space Telescope, as shown in this image taken at different times. The other telescopes were the Spitzer Space Telescope, the Gemini South Telescope, the Subaru Telescope, the W.M. Keck Observatory, and the Gemini North Telescope. The most important instrument in this research was VISIR, or the VLT Imager and Spectrometer for Mid-Infrared, installed on the Very Large Telescope. This instrument can infer temperature based on the level of infrared light emission. The fall in temperature between 2003 to 2018, that is, in the initial phase of Southern Hemisphere summers, was not the only surprising thing. Between 2018 and 2020, temperatures dramatically rose by 11 degrees Celsius. Now you would be thinking that it's okay that the temperature soared in the summers, but the intriguing thing is that Neptune has 40-year-long summers. So one would expect changes to show up gradually, and the sudden rise in temperature after a mysterious dip in the first few years of the season is strange. Given the limited data about the atmospheric conditions of this far-flung ice giant, we can't be entirely sure why Neptune's temperature is showing such dramatic fluctuations. But there are some interesting points that astronomers have put forward in an attempt to explain this anomaly. They believe that the reason behind this phenomenon is the planet's local chemistry. Despite being the most distant giant planet from the Sun, Neptune possesses a dynamic atmosphere that contains 80% hydrogen, 19% helium, and trace amounts of methane. The researchers explain in their paper that while methane absorbs sunlight and warms the atmosphere, photochemically produced hydrocarbons such as ethane and acetylene are powerful infrared emitters that serve to cool the stratosphere. The balance between this radiative heating and cooling changes as the amount of photochemical hydrocarbons change. And astronomers have seen something similar in the solar system before. For example, previous research investigating Saturn's temperature found that the interlay of chemicals in atmospheric clouds could affect their temperature, leading to temperature peaks before maximum solar irradiation, and it's possible that something similar might be happening here. But again, given Neptune's 165 Earth-year orbit, these changes are expected to occur slowly as the season progresses. And the rapid rise in temperature between 2018 and 2020 shows that there could be some additional processes operating in Neptune's atmosphere on subseasonal timescales and on both regional and global scales. It's also possible that Neptune's extreme weather has caused this abnormal temperature trend. Neptune is home to the fastest winds in the solar system. Wind speeds on this planet can exceed 1,900 kilometers per hour or 1,200 miles per hour. These winds push gusts of frozen methane through the planet's atmosphere, potentially affecting the temperature. Neptune also has frequent and massive storms. In 1989, Voyager 2 detected a gigantic storm near the planet's south pole, known as the Great Dark Spot. The storm was bigger than Earth at its largest, but by the time the Hubble Space Telescope looked at Neptune in the 1990s, it had disappeared. Finally, the researchers also investigated if the 11-year solar cycle is responsible for the temperature fluctuations on Neptune. Every 11 years, the sun's magnetic field flips, north becomes south, and south becomes north. This alters solar radiation levels, which physicists can infer from the number of sunspots appearing on the surface. Moreover, there's a loose correlation between the temperature changes and the number of sunspots on the sun over time. Still, the relationship between the two is not strong enough to conclusively support this idea, according to the new study. Whatever may be the reason behind Neptune's temperature fluctuations, the good thing is that this weird trend has been discovered and published just before the iconic James Webb Telescope begins its observations. About 6% of Webb's observation time in Cycle 1 has been dedicated to the solar system. Webb is an infrared observatory and just the perfect machine to dig deeper into Neptune's summer mystery. Of course, the only way to study the planet in great detail over the years is by sending a probe that orbits Neptune, just like Juno for Jupiter and Cassini for Saturn. But that option is not on the table, not for the next 10 years at least. Recently, NASA suggested sending a probe to Uranus as a major research priority. But as far as Neptune is concerned, for now, we'll have to continue studying the planet with telescopes on and around Earth, and the planet's summer mystery remains unsolved. If you're interested in studying astrophysics at home, check our Basics of Astrophysics series, the link to which is given in the description. This series talks about everything at the most fundamental level, from the electromagnetic spectrum to telescopes and from the physics of stars to the birth of black holes and galaxies.